I'm Alan Cheswick, and the title of my presentation is, Are You Going? Let's think about it. So a little bit about me. I'm transitioning into the field of data science after being a professional science educator for 15 years. I have a master's degree in biology. I'm a former college swimmer and men's physique competitor, and a big Trekkie who discovered data science from learning about complex systems. So perhaps you're aware of health fairs and health camps. If not, let me introduce you to MedCamp. MedCamp is a company that facilitates community health camps, which studies have shown are beneficial for improving people's lives through early disease detection and subsequent management of the disease. The goal was to help MedCamp reduce wasteful spending and maintain individualized experiences of attendees by using machine learning to predict who will and will not attend a health fair event. The metrics I worked with were false positives and false negatives. The false positives would be when you predict somebody will attend, but they do not. And the false negatives would be when you predict somebody will not attend, but they do. Now, the main goal is to reduce the total number of false positives and false negatives. The second goal is to try to keep the ratio of false positives and false negatives balanced. And that's going to be our ticket to a quality, individualized health camp experience. So the project came from Kaggle. The data consisted of nearly 38,000 patients who went to 65 camps among 9 distinct geographical locations. These camps lasted anywhere from 2 to 771 days, and there were 102,000 registrations. Now, unfortunately, many of the descriptive features for the individuals were missing, which makes predicting hard. Learning from anonymous data is also a challenge, especially when the features are named var, a letter, or a number. The vague nature of the data extended onto the units. For example, it'd be really nice to know what 0 means, especially since most of the patients had a 0 value for var1 and var5. Luckily, the anonymous categorical features were more helpful. So here's the distribution of one of the anonymized features that was one hot encoded. And as you can see, there are a lot more variations and splits and uneven splits, which makes it good for the machine learning model to learn from. I was able to create additional features using the date columns. Thank you, pandas, for date time objects. I was able to calculate the difference in days for these columns. For example, MedCamp provided the start and end date for each camp, thus I knew how long the camp lasted for. And indeed, the engineered features were shown to be among the top 6 features when I checked the feature importance. So here we can see the partial dependence plot for camp length. We can think about the y-axis as giving us an idea of the relationship between this feature and the predicted probability we expect as this variable changes, assuming the other features remain constant. This plot shows the number of days from when somebody registers for a camp, when the camp starts, and how that impacts the predicted probability that somebody would attend. Basically, the closer to the camp start date that somebody registered, the more likely it is that somebody will attend. Results from the logistic regression provided the lowest ratio of false negatives to false positives, but also had the highest rate of misclassified people. The random forest had a ratio of 2.3 to 1 for false negatives, false positives, but the overall, we predicted more people correctly. Results from the boosting model showed the highest ratio at 3 to 1, but the total amount of people who were incorrectly predicted was the lowest. So going back to historical data, this model would allow MedCamp to save up to 53%. And another way to say that is this model would save about $5,000 per 1,000 patients, assuming they spent $20 per person on individualized supplies. Important takeaways from MedCamp include The longer the health camp, the more likely it is that somebody will attend. But most people attend a health camp within the first few days that it's going on. And trying to predict outcomes for our individuals is very difficult. Future goals are to improve a neural network I made, which performed about 1% below the boosted model. But I think with some fine tuning and parameterization, it could perform better. So that would be my presentation. Does anybody have any questions?